Good morning, students. This is second class. I think yesterday we had a first class, and we had an example. Yesterday we did initial 4 examples, and I told you that you do exercise 1.1 from your side. So I marked some question to tell you. These I want to tell. Look at here. The one symbol came. This symbol and this symbol. Even yesterday I told you that this symbol is called belongs to. It does not belongs to. Question was in question number 2. We had a is equal to like 1, 2, 3, 4, 5, and 6, and some question asked that what about 5? So it means here we have to fill these one of these two symbol. Of course 5 is here, so I will write 5 belongs to A. If it is 8, so I would say 8 does not belong to A because A is not here. 8 is not here. So it's too simple symbol it is being here. I just want to introduce to you with these two symbol. This is belongs to, it does not belongs to. If element is containing A, belongs to will come. If element is not containing in A, does not belong will come. Okay, this is enough I think, because one can check it very easily by their own. So let me do question number 3rd. What is the meaning? In this particular, we have a 6 question, and all the question they are sets actually in the set Belter form. You have to convert in a tabular or roster form. So you have to prepare or make a roster form. This is a question actually. So how to make the answer? So third I'm rising, not all. Third I'm rising. Question says C is a set X such that X is a two-digit number such that the sum of digit is 8. Not whole question I'm writing, but the major part I have written here. X is a two-digit number such that sum is 8. The sum of digit is 8. So you have just to search about the two-digit number whose sum is 8. So definitely it will come from 1, 7, 17, 2, 6, 2 and 6, 8, 26, 3 and 5, 35, 3 and 5, 8, definitely double 4, and just opposite of 35 is a 53, then 62, then 71, and one thing which actually normally student drop, it's a 80. But don't write 08 because one should know that it is not a two-digit number. It is a one-digit number, because this is a nonsense here. So finally, I have told. I think in one side, in one writing, you have got this question. Nothing hard is here. Now I will take some more question in same question. Question number E. What is the question? The set of all the letters. Question was that E it is a set. The question says the set of all the letter of word trigonometry. This is a question. Now let me speak something that you have to name it E and just go with the roster form. These are the letter of the word. You just have to arrange in a set form, roster form. But keep remember that if T is here, so again T you cannot write. So this is a very important thing I'm telling you, that while making or constructing the set, you just can write a single letter a single time, or anything single digit. If it is coming, digit will be single time. Like what T and TS twice, but you just have to write once. R is coming 2 times, but you have to write once. Then I is coming single time, you have to write that. G is coming single, you have to write that. O is coming twice, just once you have to write. Then N is coming once, you have to write. Then M is coming here once, go through this. And E already have written. Sorry, E is not yet to write. It is yet to write. R already have written. Y have to go with this. So whatever it is, it is a particular roster form of the letter of the word trigonometry. The major thing which I already have told you, that don't repeat the letter in the single set. This is important. That's why I have put this particular example. Okay. Now once more, question says, I think it is the last of the third is also same, so you can do by your own. Question number 4, it is again important. I want to, so it is a form Sedgwick form. Sedgwick form. So see quick. First I am telling you. Now suppose it is A. Suppose it is A, and this is 3, 6, 9 and 12. Only this. This is till 12. Now we want to make its Sedgwick form. Sedgwick form meaning sentence wise you have to make. Yesterday we had a good class. I taught you in that class only that how to write Sedgwick form, how to write roster form. This is a roster form or tabular form. You have to convert this in a Sedgwick form. So how will write? We'll write. Look at this is 3, 6, 9, 12. It's just like a table. 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12. So this is will be written x equal to 3n. Very simple. X is equal to 3n, where n is a natural number and where n is a natural number. This capital N is a set of natural number and it belongs to. And specially restriction that if n is a natural number, meaning n is a 1, 3 1s are 3, n is a 2, 3 2s are 6, n is a 3, 3 3s are 9, n is a 4, 3 4s are 12, but n is not 5. 5 plus 15 is not here. So we have to restrict the natural number from 1 to 4. Like it is 1, 2, 4. Meaning you just have to put your n from 1 to 4. May possible that this answer is not matching with the answer sheet back of the book, but it is a correct answer. You have to make the habit to make this kind of a Sedgwick form from your side. It is not wrong. So 1 less than or equal to n less than or equal to 4, meaning you can put n equal to 1. Yes, 3 1s are 3. You can put n equal to 2, 3 2s are 6, n equal to 3, 3 3s are 9, n equal to 4 lastly, 4 3s are 12. But further, beyond of this range, n is not possible. Okay, this parallel I want to explain question number 4 first. Look at 4th. Suppose it is a B. Suppose it is B. 2, 4, 6 and so on. This is a simple and similar question. Look at it. 3 2s are 6, 3 3s are 9, 3 4s are 12. It was a table. 2 2s are 4, 2 3s are 6, 2 4s are 12. Like it is a table. So same work will come, but very good thing it is have no boundation. It is infinite. So I would say that writes as it is, x is equal to x such that x is equal to, this is a table of 2n, where n is a natural number and only this. So why I haven't put here this condition? Because this time the criteria only 4 object we had in a set A. This time it's infinite. So one by one you can put all the natural number. When you put 1, 2 1s are 2. When you will put 2, 2s are 4. When you will put 3, 3 2s are 6. When you will put 4, 4 2s are 8 until infinite. So that only will be written like that. So make a habit to write. You can easily pick it. Just try to see the video twice and thrice. You can catch it easily. Okay. Some more question. Like question number 2nd. Suppose it is a C. 2, 4, 8, 16 and 32. This is a question. And similar question is 5th one. Sorry. Similar question is 3rd one. So 2nd I am telling you, 3rd you make. What about that? What is the difference between these two kind of question? This was a table. 3 2s are 6, 3 3s are 9. This is not a table. 2 2s are 4. 2 3s are 6. No, it is not 6. It's 8. Actually, 2 2s are 4. 4 2s are 8. 8 2s are 16. Or in second way, in rough work, in extra section, you can see that it is 2, not it is 2 to the power 1. It is not 4, it is 2 to the power 2. It is not 8, it is 2 to the power 3. It is 2 to the power 4. It is 2 to the power 5. Enough. Alternatively, you can write this as like that. So it will give you information that how to write. It is 2, meaning I will write only 2. But in power it is varying, like 1, 2, 3, 4 and 5. What is they? What are they? They are natural number till 5. So I think you have got till now that I will write x as that x is equal to everywhere 2. So I will write 2. And what is changing? 1, 2, 3, 4, 5. This is changing. This is changing. So hope student you are getting that x equal to 2 to the power n, meaning when n equal to 1 it will come, when n equal to 2 it will come, n equal to 3 it will come, n equal to 4 it will come, n equal to 5 it will come, but n equal to 6 I cannot put, because this is not till infinite. When it would be till infinite, you will rest your answer here. But this time you have to write where whatever the n, you know that it is a natural number, and give the restriction of n, which is from 1 to 5. So 1, 2, 5, this is a restriction. 1, 2, 3, 4, these are n. So restriction from 1 to 5, this is forming this particular set. So hope you have got. If it is still infinite, you need not write that, but if it is restricted, you have to bound your n like that. Okay, so this was C. And similar question is a third one. You can make it. I am telling you fifth one. And suppose it is D. 1, 4, 9, same. It is again same. 100. So again same. Both are same actually. Look at 1 is not 1. It is actually 1 square. It is not 2 square. It is 3 square. 4 square. 5 square. But it is bounded 10 square. So same there. Same there. It is still 5. Because 2 to the power 5 was coming, it is still 1, 2, 3, 4, 5, meaning what? The changes is being, okay, 1, 2, 2 is 4, 2 is 8, 1. Oh, they are different actually. Oh, look at, I tell you, they are different. It was 2, 1, 2, 2 to the power 1, 2 to the power 2, 2 to the power 3. It is not so. It is what actually? 1 square, 2 square, 3 square and 10 square. So what is changing and what is constant, you have to look at. And both are actually not same, but the quality of questions are almost same. I tell you one thing, the nature of the question is almost same. Here the power was changing, base was same. Here the power is same and base are changing. So what is changing? This is your x. And I tell you that how to think about that. D is equal to x such that x is equal to, this is 1, 2, 3 and 10. Now what 1, 2, 3, 10? They are natural number. So I will write n. And what is constant? 2, 2, 2, 2. So it's a 2. And what is n? N is a natural number. You want to check yourself, look at. When n is a 1, so 1 square is 1. When n equal to 2, 2 square, 4. And n equal to 3 is 9. Simple. You don't have to write this term, but just write directly here. And what is n? You know that n is still, I just made you write here 1 square, 2 square, 10 square. So what is n? Base 1, 2, 3 till 10. So I have foundation that your n is till 10. So hope students are getting. If you're still confused, you can write by your own, no matter at all that if you write like that, it is still acceptable, no matter at all. Now it is also, you can write here that c is equal to 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. You can write, no matter at all. So both are correct, but just think about, here the base was same, past changing, so power was n. Here the base same and power is same and base is changing, so base is n. So which is changing, put it n. So hope you have got till here. So this is the question number 4 I wanted to discuss with you. The more thing is question number 5. Question number 5 here, question says list all the element of the following set, meaning we just have to go with again the roster form. List all the element, meaning you have to form the roster form. Okay. Question, we have a few questions, but I'll just take question number 2, where b is equal to x such that x is an integer and half less than x less than 9 by 2. Very good question it is. So let me speak. Sometimes student not getting this thing properly, that what is its meaning. You don't need to afraid. I tell you that you just have to make the set. So what is its meaning? First you have to think. I tell you one thing, if you are afraid about, just go through the number line. It will give you answer. It is infinite, it is infinity. Plus infinity, minus infinity. It is an integer line. Okay, it is an integer. So what are restrictions are given? 1 by 2. So what is a 1 by 2? You should know 1 by 2 meaning 0.5. So it is, suppose it is 0, 1, 2, 3, minus 1, minus 2 and so on. Where it is located? Minus 1 by 2 is located, meaning minus 0.5. So minus 0.5 is being here. It is minus 1, so minus 0.5 is here. And it is 9 by 2, meaning 4.5. So where is a 4.5? 4. It is a 4.5. So you have to write that your x is lying between these two. Your x is lying between these two. And between them, search what the integers are. So your answer with you now, you just have to write the integers. Integers, this is not an integer, this is a rational number. But now look at this integer, we don't have to write these two. These two are not integer. Integers are never in decimal sign. So integers start from between them, we have integer 0, 1, 2, 3 and 4. So you have to write only 0, 1, 2, 3 and 4. And that is enough. That is enough. So hope student you are getting that. First I changed in a decimal, then I made a number line, and I plotted all the points where from where I could get answer, and I have written the answer simply. So this is the answer of the question. Hope you have got. Not a so tough that I have to explain once again. Okay, question number 3 is also very easy. Let me explain that. It is a last from my side only. Now you do from your side. X is an integer which satisfy x square less than or equal to 4. What is its meaning? You just have to choose all the integer which satisfy this. Can you put x equal to 5? No. 5 5s are 25, which is not less than 4. So you have to choose from your side. X is an integer which satisfy this one. So I don't think that I have to tell you long. This is first integer is 0, because 0 will put it is satisfying. Can you put 1? Can you put 1? If you put 1, 1 square is less than 4, yes. Can you put 2? So 2 2s are 4, which is not less than but equal to. Both signs are available here. So 4 is equal to 4, meaning it is satisfying. 2 also. Sometimes student get confused and he or she writes till here. But he and she must remember that integer is also negative value. Minus 1 also will be there. Because minus 1 square is itself 1, which is less than 4. And minus 2 again, when I put here minus 2 square, meaning 4 again is equal to 4. So these 5 values will be answered. So hope student, this is a exercise first till here you have got all the things properly. So want to go ahead just tell you the simple types of the set quickly. First, empty set. Types of the set I am telling you. First, empty set. It is very clear. Null set also. It is also called null set. It is very clear with the name, empty set. Meaning the set containing no element. No element. If I write something that A is a set, X such that X is a student of the school studying in class 10th and 11th. So a really funny sentence I have written. But you have to name X is a student, write the name of the student who is studying in class 11th and 12th. Funny sentence, because a single student cannot study in both the class together. So it is the set is null set because it will not contain any element. So the set will be written like that. So you just have to use a curly bracket without using any element. Or you can also write phi. It is a phi. It is used for null set. Wherever in the section of set, in the chapter of set, if phi is coming itself, meaning empty set. You don't need to go like that. It is a wrong. It is a wrong. A null set can be denoted by two ways: either only phi or only a curly bracket without writing any element inside it. So these two ways are empty set. Okay. Now next is empty set, we have a finite and infinite set. These are very simple, finite and infinite set. So hope this is very simple. I have yesterday explained that those set have a countable number of element called finite set, this is a set of vowel of English alphabet, because they are 5, they are countable, it is a finite. If I ask you what is n, the set of natural number starts with 1, 2, 3 and so on. So it is uncountable. That's why it is called an infinite set. So this two simple example, we can by these example we can understand that what is a finite set and what is a infinite set. Okay, we have equal sets, very simple equal sets. Okay, I now ask you one thing, that what is equal set? Equal set meaning after creating two, we will just talk about two sets which are in roster form, because roster form clear the condition. If I am writing a is equal to a e I o u and b is equal to that e a o u and I ask you that what about these two sets? Even the elements are in a different order, but elements are equal. So when elements are equal, sets are also equal. So this is a very simple sentence for equal set. Equal set, these two are in roster form. If I write instead of that a, x is that x is a vowels or x is a letter except consonant. Try to understand this. If I write that a is equal to x such that x is a letter except consonant, so except consonant, what remaining? Only vowels. And this is a, e, I, o, u vowels. And if I ask you the nature of a and b, they'll be equal. So you know this kind of set, when you try, you will find its roster form. You will definitely get a, e, I, o, u, and this is again a, e, I, o, u. Order is not important; both will be same. Okay, this is equal set. I think it is you have got till now. Very simple. Okay, so you just try to do example 7 and 8. Tomorrow we'll start some example along with the exercise. Thank you.